So there are a couple of ways to determine a derivative. One of the methods we're going to use today is just the difference quotient, which the formula is stated below. So S of t means position. If I find its instantaneous velocity, that means I'll be finding its derivative because a derivative is an instantaneous rate of change. So you don't have to write it in terms of t, which is time, if you don't want to. If you're more comfortable with writing it in terms of x, because that's the variable you're used to, that's fine. You can always change your function in terms of x rather than t if that helps you. So using the formula for the difference quotient, I need to first find out what f of x plus h is. So that means that f of x plus h, notice that the only thing I did, even though I'm given f of x, is replace the x with x plus h. So that's the same thing I'm going to do here. Instead of 12x, it's going to say 12x plus h, because anytime I substitute anything with an expression, meaning plus or minus, it should be in parentheses. Drop down the plus 5. So after distributing, this will tell me 12x plus 12h plus 5. So I have everything I need in order to start my formula. Keep in mind that the formula neglects in front, since you're finding the limit. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to plug this into the formula in order to find the derivative. So the limit as x approaches 0, f of x plus h, notice that we already have what f of x plus h is. It equals to 12x plus 12h plus 5. So 12x plus 12h plus 5. And then it says minus f of x. So keep in mind that f of x right here is also an expression, meaning it has a plus sign. So when I substitute f of x into the formula, I need to substitute it in parentheses. Always substitute any expression, anything with a plus or minus, in parentheses, because you may have to distribute. If you don't, then you can remove the parentheses, but at least you're always prepared. And this is all over h. All I'm going to do from here is just work on simplifying the numerator. Now, notice there is a negative in front of this parentheses, so in order to take each term out of the parentheses, I'm going to distribute the negative. So this will give me negative 12x minus 5. So if I'm combining like terms here, I have 12x, I have negative 12x, that's gone. I have positive 5, I have negative 5, that's gone. And this leaves me with 12h over h. So the h's divide out here, leaving me with just 12. And that's the derivative or instantaneous velocity. Hope this helps.